third period. Okay. So this question is on the quick review. You've already done the first start, which is a review for your quiz for tomorrow. But this second part is something new. How do you solve for x when you can't get the bases the same? 3 is not on your powers chart for 2. You know 2 to the 1, and you know 2 squared. And 3 is somewhere in between them. So a guess might be, maybe it's 2 to the 1.5. But if you go to your calculator with that guess, 2 to the 1.5, is it equal to 3 exactly? Not quite. It's 2.8. So you need a little bit more than 1.5. I mean, we could guess and check until we get really close. Ooh, 1.6 is too much. So now we know it's between 2 to the 1.5 and 2 to the 1.6. But if we want to find it exactly, we need to use logarithms and our laws of logarithms. So when I have 2 to the x equals 3, okay? And there's more than one way of solving this, but this is going to be the most typical way of solving these for all calculators that have just the log button or the natural log button. If in mathematics you do something to one side of the equation, you have to do the same thing to the other side so that they stay equal, right? 5 is equal to 5. If I add 3 on the left, it's now 8. I have to add 3 on the right to keep them equal, right? It's not equal to the same numbers as they were before, but the equation is still equal. So if I have an exponential equation, one of the things I can do is I can take the log of both sides. Now initially this makes things look more complicated. But you have a log law, especially for exponents. Your log law says if you have an exponent inside of a log, you can bring that exponent out in front. Well, that would let me have x log 2 equals log 3. And although this looks complicated, this is exactly the same as when you have x times 5 equals 7. What would you do mathematically? Normally, you wouldn't write x times 5. Well, you'd probably write 5x's, right? And if you had to solve for x, you'd divide by 5. Those are numbers. Well, log of 2 is a number, even if you don't know what it's equal to. And log of 3 is a number, even though you don't know what it's equal to. So I could divide both sides here by log of 2. That will get x by itself. And we get log 3 divided by log 2. And now if we go to our calculator, we can type that in. I'm going to use the fraction button. I'm going to type log 3 on the top, log 2 on the bottom, and push enter. And look, it was between 1.5 and 1.6. It's 1.584962501. How long would that have taken us to guess and check? Not too long, but it would have been a little bit annoying. Okay? Now we have a method of finding it exactly. And the really nice thing about exponential equations is after you find your answer, I suggest you hit the store button and store it as x, and then use that value of x to check if you're right. What was the original question? 2 to the x equal to 3. I'm going to check. If I do 2 to the x and I push enter, is it equal to 3? Because if it is, we know that our answer is completely right. If it's not, we know that we screwed up somewhere. It works out perfectly. This technique of taking the log of both sides is really helpful for all sorts of exponential equations. Sometimes, like for ones like this, there might have been a few of you that thought, what happened if I just change it to log form? if I have an exponential form 2 to the x equals 3, the log form of this, the base is 2, the answer is 3. Oh, I get x by itself that way too. And although this works, I'm going to recommend the first technique that we did because it's going to work for all sorts of log equations. But if you go to your calculator and sure enough check if you're able to do the log base on your calculator, log base 2 of 3, you get the same answer of 1.58. But many calculators don't have that log base, and so the other method helps us solve no matter what the equation is. Because changing it to log form only works if you have a single exponent, like in this case, a single power. But if we look at the next example on your sheet, this isn't a single power. We've got 2 times 3 to the x equals 5. So again, we start off by taking the log of both sides. If I take the log of one side, I take the log of another side. Now here, you're going to be tempted to bring the x out in front right away. But we have to be careful because when we practiced all that expanding stuff at the beginning of the unit was for solving equations eventually. And if you had to expand the left-hand side, your log law for bringing an exponent out in front, which is up here on the wall, it works when the exponent is to the entire thing inside the log. But if we look inside that log, can you see that the exponent x is only to the 3? That exponent x is not to the 2. And because it's not to the entire thing, we can't use that log law yet. But what else do we see inside of this first logarithm? It's 2 times 3 to the x. What can you do with multiplication? You can add. Love this when I take out the words. What can you do with multiplication? Oh, you add. Okay, perfect. So we have log of 2 plus log of 3 to the x. And now can you see that that x could come out in front and equal to log of 5. Again, we have log 2, log 3, log 5. Those are all numbers. If you had a simpler equation with numbers, 2 plus 3 to the x, 3x equals 5, how easy would that be to solve? You'd move the 2 over, then divide by 3. Mathematics doesn't get, okay, I wanted to say it doesn't get more complicated, but then you'd say I was a liar. Mathematics doesn't change its rules. Its rules just appear with different things. So here, I know how to solve this, so I know how to solve this. I would subtract 2 on both sides. So I'm going to subtract log 2 on both sides. I would then divide by 3. So I'm going to divide by log of 3 on both sides. And I get log of 5 minus log of 2 divided by log of 3. Am I right? I don't know, but we're going to find out. So once again, what we can do with this is we can go to our calculator. I'm going to use the fraction button again, or attempt to. Here we go. And on the top of my fraction, I have log of 5 minus log of 2 divided by log of 3. And I get 0.834. Do I know if this is right? Not yet. But again, I'm going to store it as x and say, what was my original question asking? My original question, scroll up to it, was asking 2 times 3 to the x, is it equal to 5? So I'm going to go to my calculator now and go 2 times 3 to the x. Wow, that looks like 23 to the x. Let's try that again. 2 times 3 to the x. Is it equal to 5? Yes, it is. So then we know that our answer is right. So some people really like the logs unit and the exponential unit because when solving, they know if they've got the question right. It's always on a calculator part. Once you get your answer, you can always plug it back in. In fact, on your quick review of log laws, I tell you, you can only find out if your answer is right by checking it. You have to plug it into your calculator to check it. There's no answer key because you should know by checking it whether you're right or not. Now, I'm going to take this question. We're going to change the view, zoom, entire page. I'm going to take this, group it all together, make it smaller, off to the side here. What did we get as our answer? 0.843? 834? Close. Right? I knew I had the right numbers. Does the order really matter? No. You could just write on every single math question, 1, 2, 3, 4, 5, 6, 7, 8, 9. The right numbers are in there somewhere. Okay. Last one that we're going, well, maybe we'll do one more. You have x in the exponent. Both 5 and 3 are not on your same column of your columns chart. So these questions come in 2 ways. One is calculator, one is non-calculator. If it's non-calculator, you can always use your powers chart and the method that we learned earlier. But when it's calculator and they're not in the same column, then you have to use logarithms. Oh, I was going to show you something on the last one. Before we get to this one. I took log base 10 of both sides. Can you see that I could have taken log base 5 of both sides and done the same thing all the way through? The laws stay the same. And so what happens in a lot of higher level math is they don't take log base 10 of both sides. They take the natural log of both sides. The log laws are the same. If you're multiplying, you add. Bring the x in front now. Subtract log 2 on both sides. Divide. By natural log of 3. Type this into our calculator so I'm not lying to show you that it works out the same. Natural log of 5 minus natural log of 2 divided by natural log of 3. We get exactly the same answer. And if you use the natural log, you will save 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters, which at about 0.03 milliseconds per letter will save you 0.33 milliseconds per question. So does it really matter? Yes. No, not really. But you do have to write just a tiny bit less to get the right answer. But some people don't like natural log because this is easy to say, log, and this one's it just doesn't. You have to say the whole word, so maybe if you're more efficient speaker-wise, you don't like natural log. But it comes out to the exact same number. And we could have taken log base 8,357,802. But then we'd have to write that base every single time. Not recommended. But it would give you the same answer. So we see x in an exponent. The main strategy that we're going to have is that we're going to take the log of both sides. So starting off with that, do you want log or natural log? What are you in the mood for? Your natural log? Okay. Few less letters, thank you. So if I take the natural log of both sides, can I use the exponent rule to bring it in front? Yes. And I'm going to make a common mistake students make in this next step. Bring out the x minus 1 in front. Bring out the 2x plus 3 in front. There's the common mistake. What's wrong? I need brackets because this gets the way this shows right now, it says x minus 1 natural log of 5, but the exponent multiplies, so we do need brackets around there. What happens if you have a 5 in front of brackets x minus 1? What do you do? Right? What would you do if you had this and you were simplifying? You'd expand it. You'd distribute the 5, right? So natural log of 5 is a number. This is probably one of the confusing things about logs unit, is when are things a number and when aren't they a number? If you can type it into your calculator, it's a number. And if you can type it into your calculator and it gives you a number, aka natural log of 5, that is a number. Okay? Sometimes students think this is a number. Log base 5 of nothing. Log base 5, is that a number? You push enter. No, it's an error. That's not a number yet. But if I put a number inside of it, log 5 of 12 is a number. So when is something a number and when isn't a number is going to be important. And this is going to come back a little bit later, but I'm introducing it now. The key thing right now is natural log of 5 is a number, and you're able to distribute numbers. Can you tell me something you're not allowed to distribute? You're allowed to distribute numbers. Natural log of 3 is a number, so I can distribute it. But I want you to think of something you're not allowed to distribute. Mathematically, we're not going to talk about distributing illegal pamphlets during World War II or anything like that. Okay. Now, again, the idea of algebra stays the same. We just deal with more complicated things. If you had 5x plus 3 equals 7x minus 9, what would you do? If you were solving? You give up? That's way too hard algebra. That's like going, that's grade 9. I can't remember back that far. That's a nice thing about math. What we do in grade 9, we keep doing over and over again. So when you see that, you're like, yeah, I've done that so much. I'll combine my like terms, move things over to the same side, right? You'd probably move your x's all to one side and your numbers all to the other side so you can combine them. Okay? We're going to do the same thing here. We're going to say, I'm going to get all my x's on one side. So I'm going to subtract 2x natural log of 3, natural log of 3 on this side. And on the other side, I'm going to put all my numbers, 3 natural log of 3 plus the natural log of 5. Now, when you had numbers, these things combined nicely. When you have logarithms, they don't combine as nicely. However, if I've got an x in this term and an x in this term, how do I get a single x? I can factor it out. If I factor out an x out of both of those, In my first term, I'd be left with just the natural log of 5. In my second term, I'd be left with the 2 and the natural log of 3, but the x has been factored out. On the right-hand side, I still have 3 natural log of 3 plus the natural log of 5. And with this, I can now get x by itself, because now it's x times this number. What do I need to do to that number? I need to divide both sides by that number. So again, when we talk about things being numbers, it's a little bit easier for us to do the math. If I just showed you this with natural logs, oh, we're going to divide by this, you'd be thinking, is he making up new rules? Do I have to memorize new rules with logarithms? Not really, because the rules are staying the same. If you can make that connection, your life becomes easy. So I'm going to divide by this number. And our answer looks kind of nasty. Do we know if we're right? Not yet. We go to our calculator. Use your fraction button, otherwise you have to do a lot of brackets. Type in exactly as it shows, 3 natural log of 3 plus the natural log of 5 divided by the natural log of 5 minus 2 natural log of 3. So I've typed it in exactly as I have it there. I push enter. And I'm going to store this as x. Negative 8 no, I did not store it as x. I hit the wrong button. Try that again. So get my answer, then hit store as x. Perfect. Negative 8.35. To check if I'm right, my original equation said those two things should be equal. So I'm going to type into my calculator 5 to the x minus 1, because that was my left-hand side of my equation. And my right-hand side was 3 to the 2x plus 3, 3 to the 2x plus 3. If they're equal, my x value is right. If they're not equal, we made a mistake somewhere. So again, what's nice about logs is when they tell you you've done things right, you feel good. What's not nice about logs, if you do this and it's not right, then you for sure know you did something wrong and have to redo it and start it again. In the end, if we summarize sort of what's been happening along the way, we take the log or natural log of both sides and use our log laws until we can get the exponents out in front. Sometimes that exponent can come out right away, but sometimes, like the last example, we had to use another log law of adding first before we could do that. Then we use our algebra skills to get x by itself. In this case, when there's more than one x, you're going to have to factor. So I think there's a note in your additional notes there to factor both sides. If there was only one x, life is easy. You just get that term by itself. Then you divide, type it into your calculator to check. And we're able to solve all sorts of equations that we couldn't solve before. This is the first time in solving for x that x has been an exponent and you can solve for it. And our log laws help us do that. Now, I had asked earlier, you can distribute a number, but what's something you're not allowed to distribute? Anyone come up with any ideas? Sine alpha plus beta. Can I distribute the sign? No. We have a formula, right? You have a formula that you know that this is sine alpha cos beta plus cos alpha sine beta. But I can't just go sine alpha plus beta. That's wrong. Because sine isn't a number. Sine is a function. So functions are something you're not allowed to distribute. And they're going to be so tempting to distribute in this unit. Because, check this out. Log of 5 is a number. This you could distribute. Log base 5 isn't a number. But you are, oh, some of you are going to do this. Oh my goodness. Lightning should strike me right now for showing you that on the board, because this is wrong. Make you tempted to do that. So we have to make sure that we know that we can distribute numbers. We can distribute variables because variables represent numbers. But we can't distribute functions. All right. So take out your quick review of log laws and either work on your own or pick a partner and grab a whiteboard marker and do some up on the boards and do the first 5 on exercise 1, A to E.